Welcome to the Neuromodulation podcast, presented to you by the International Neuromodulation Society. Dive into the forefront of today's emerging neuromodulation techniques, insights, and ethical and clinical applications. Subscribe now to join the multidisciplinary collaboration of medical care providers, scientists, and engineers who are part of the global conversation that's shaping the future of healthcare. Welcome to the Biostatistics articles live reading series, presented by the International Neuromodulation Society and developed in collaboration with the Newcastle Cognition Lab at the University of Newcastle. I'm your host, Mandy Soleil, and it's a pleasure to have you here. We're pleased to offer this ongoing series of short articles explaining how to critically apprise clinically relevant literature to evaluate evidence and inform practice. The entire series of articles is available on our website at www.neuromodulation.com/biostatistics-articles, and a direct link to this article is available in the episode show notes. We've translated each article to a live episode on the Neuromodulation podcast to bring versatility and ease to your statistics learning journey. Each primer features a single topic and an example within the context of clinical neuromodulation research and practice. Upon reading and/or listening to these articles, learners will be able to understand statistical methods, their interpretation and their limitations, identify cognitive biases to avoid inadvertently misinterpreting evidence, and interpret data for a deeper understanding of clinical research to inform clinical practice. And now, I present to you Professor Konstantin Slavin, head of the Stereotactic and Functional Neurosurgery section at the University of Illinois Chicago, or UIC, and president-elect of the INS. His term as president begins September 1st, 2024. Thank you for tuning in.
The next issue of Biostatistic articles written for International Neuromodulation Society deals with the Fragility Index. It is written by Garston Liang, Alexander Thorpe, and Quentin Gronau. The caveats include key features and key considerations. Key features are that fragility is the number of participants needed to switch a statistical outcome, meaning that how many n can switch groups until significant with probability of less than 0.05 versus not significant with probability above 0.05. A key consideration is that higher fragility index is better. The alpha criterion with probability of less than 0.05, perhaps 0.01, what counts as a clinical event, and the sample size. Part 1. Tipping the scales. If one does not count their local grocer, perhaps the most recognizable set of scales are held by Lady Justice or Justitia. The Roman goddess had traveled long and far to sit atop courthouses across the world, and most remarkably, all without the help of her eyes. In our modern consciousness, her blindfold is what makes the scale trustworthy. It symbolizes impartiality across wealth, power, and status for each and for all. Yet, could even this famous blindfold be another fashion trend? The figure to illustrate this has scales with n of recovered people on one side and two figures there, and n of sick patient with two figures there as well. The fragility index equals of how many people need to change places. P-value maybe was written with alpha, and Fi was 4 with 3 people on one side and 1 on the other. Atop Old Bailey Courthouse in London, Lady Justice does not wear a blindfold, nor do her depictions upon early Roman coins. In fact, historians have traced the trend to be a 16th century addition, before which the scales had always been well within Justitia view. And surely this makes for sounder judgment. Not only can one feel whether the scales are even, but only without the blindfold can one see the quality of the evidence on trial. A touch-up here with a chance event there, and the entire balance may no longer feel so secure. In this primer, we examine the Fragility Index, Fi, that measures whether a p-value based conclusion will be revised should one or two pieces of evidence change places. Often, the p-values of randomized controlled trials, or RCTs, are put to trial when the Fragility Index, or FI, is used to understand whether substantial resource commitment has yielded reliable outcomes. Perhaps, when armed with such a sword, it could be prudent to take off the blindfold and ask, when does the balance tip? Part 2. The Fragility Index and Fragility Quotient. Imagine an RCT finds that treatment A is superior to treatment B with probability of P equals 0.04. But should a single person have swapped outcomes, then the probability will be above 0.05. That's fragile. The Fragility Index calculates the number of participants needed to change the significance of p-value based set, meaning that probability of less than 0.05 to probability of more than 0.05, or vice versa. The Fragility Index is calculated by re-evaluating a p-value after an individual clinical outcome is recoded from one clinical category, meaning recovered after treatment, to another, meaning that still sick. After each change, the p-value is compared against the nominal alpha value, typically alpha equals 0.05. And so the I, or Fragility Index, is the total number of participant changes to cross to the other side of the alpha criterion. As a metric, the Fragility Index is directly interpretable as a number of participants. A lower Fragility Index indicates that the conclusions of the study hinges upon a small number of participants, whereas a higher Fragility Index indicates that the conclusions are robust against many changes in clinical outcomes. There are a number of factors that affect the Fragility Index, but prime amongst these is the sample size. How one interprets the fragility of the Fragility Index equals 4 will be different if number equals 20 or 200. To address this gap, the Fragility Index can be converted into Fragility Quotient, which is Fragility Index divided by number. In effect, the normalization over sample size permits a comparison between studies with different numbers. The Fragility Quotient values are constrained to value between 0 and 1, as compared to integer Fragility Index values. And high Fragility Quotient values indicate that p-value based conclusions require a greater proportion of the sample to change places. As an example, with Fragility Index equals 4, study A with number n equals 20 has Fragility Quotient of 4 divided by 20, or 0.2, whereas study B with number of 200 has Fragility Quotient of 4 divided by 200, which is 0.02. The Fragility Index has enjoyed a recent resurgence in the medical literature as an aid for understanding the outcomes of randomized controlled trials. The typically large numbers alongside statistical corrections for confounding factors are why conclusions from randomized controlled trial provide the clearest and largest pool of evidence for a treatment's efficacy. Surprisingly, however, many randomized controlled trials have low fragility indices. Recently, Xing and Lin in 2023 surveyed clinical studies in Cochrane Library and found that 20% of statistically significant results hinged on the outcome of a single participant with Fragility Index of equals 1. This stark contrast between methodological strength and statistical fragility in randomized controlled trials adds a recent call for better statistical understanding in the medical field. Part 3. What is fragility? Although the Fragility Index is numerically easy to interpret, where fragility precisely begins and ends is hard to know. It may be relatively easy to see a Fragility Index of 1 and agree that much of the interpretation hinges upon a single outcome. However, should we learn that this clinical outcome is known a priori to have an extremely low prevalence, it becomes harder to imagine how many rare events would make a convincing Fragility Index. Critics have argued that dichotomizing fragility mirrors the problem of p-values by placing undue weight upon significance. In fact, the comparison to significance testing is more than skin deep. Statistically, the Fragility Index is inversely correlated with p-values and suffers from the same malaise. Sufficiently large samples will yield statistical significance even without a meaningful difference. Along a similar vein, The fragility index is not a measure of effect size, and so a change in an individual outcome status, meaning recovery from sick or vice versa, also ignores the magnitude of the person's symptoms or recovery. Like the p-value, the fragility index should be considered as only one index of robustness amongst many. Below, we detail a range of fragility index-related factors to consider when deciding whether to trust the robustness of the study conclusions. Part 4. Factors affecting fragility. Outcome types and effect sizes. A fragility index is straightforward for binary discrete outcomes. For example, randomized control trials measuring the incidence of death in control versus treatment arms can easily recode an outcome from one category to another, bearing in mind that fragility index is entirely silent on all the shades of gray between death and health. For continuous outcomes, such as scores in psychometric assessment, the fragility index can be applied with minor adjustments. One continuous version adjusting the measured outcomes would be to discretize the continuous outcome variables, meaning scores below 5 out of 10 are unhealthy and scores higher are healthy. This option requires justification of why one chose a particular threshold and the trade-offs in information load when collapsing the continuum. A second continued option, adjusting group membership to randomly select a single participant, is to switch groups and calculate the fragility index. The same process is then bootstrapped and repeated many times, and across increasing numbers of participants. In effect, this provides a fragility distribution, where for each numeric participant change, a distribution of p-values is obtained that can be compared to alpha. In either case, it is worth noting that fragility index Fi focuses on primary outcomes, and so secondary outcomes are ignored. Alpha, choice of statistical test, and reverse fragility. The fragility index is tied to the choice of alpha criterion. While convention is that alpha equals 0.05, different alpha would yield a different numbers of outcome changes to alter the outcome's significance. This is worth considering when comparing fragility index or fragility quotient across randomized control trials with different thresholds. Similarly, the exact choice of statistical test can affect what the p-value that is derived. P-values for discrete outcomes could be generated from Fisher's exact test, chi-square tests, or odds and relative risk ratios. In fact, when the same data are converted from one format to another, it's possible that fragility index equals 0, where only one test yields probability of less than 0.05. As a final note, the fragility index is not exclusively tied to randomized controlled trials with significant outcomes. One can imagine the reverse application for non-significant results, momentarily putting aside the overtones of post-hoc power calculations. Speculatively, one could examine the number of outcome changes that would have produced a significant result. For the literature more broadly, the transparency requirement of funding agencies has likely bolstered the number of published studies once destined for the file drawer. Such work could be suited for reverse fragility index. Recommendations. Just like with p-values, interpreting only a single metric is risky. Our recommendation is to examine the context contributing to the fragility, such as data generating process or how the randomized control trial classifies outcomes, to understand better quality of the evidence on trial. Further reading. Larger scale fragility index assessment of clinical randomized control trials in Cochrane Library is described in Xing and Lin in 2023 in the Journal of Evaluation in Clinical Practice. The fragility index and specific case examples for randomized control trials in different specializations is illustrated by Tignanelli and Napolitano in 2019 in the journal JAMA Surgery. The reply on 2 highlighted shortcomings of fragility index is listed in the paper by Acuna and colleagues in 2019 in JAMA Surgery as well. Thank you.